For this problem, it says on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by g of t, which is equal to 90 plus 45 cosine of t squared over 18. T is measured in hours, and t is in between 0 and 8 inclusive. At the beginning of the workday, t equals 0. The plant has initially 500 tons of unprocessed gravel. During the hours of operation between 0 and 8, the plant processes gravel at a constant rate of 100 tons per hour. Part A says find g prime of 5. Using correct units, interpret your answer in the context of the problem. Since a calculator is permitted on this problem, let's go ahead and type this as our y1. So we have g as our y1, and we need to find g prime of 5, so we're going to go math and then press 8. So you're going to type x, and then right here, our g is our y1, so let's call up y1. I'm going to go alpha trace, and right here is y1, and we're evaluating it at 5. So go ahead and plug in 5. So you get negative 24.588. So I just wrote that out. G prime of 5 equals negative 24.588. So g prime of 5 represents the rate at which gravel is arriving is decreasing by 24.588 tons per hour at the time that t equals 5 hours. Make sure when you're writing your interpretation out, you use the words rate and then either increase or decrease. We used decrease because g prime of 5 was negative. Include the value. Make sure to include the units. So here it was tons per hour, or you could say tons per hour squared, and then specify when it occurs. And so this one occurs when t equals 5 hours. Part B says find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. Since G represents the rate at which unprocessed gravel arrives at the gravel processing plant, and the workday goes from 0 to 8, we're going to integrate from 0 to 8 g of t dt. So I have that set up right here, the integral from 0 to 8, g of t dt. Just a reminder, we have g of t as our y1. So we're going to go math 9. We're integrating from 0 to 8, and we're going to call up g of t, which is our y1, and we get 825.551. So we have 825.551 tons of unprocessed gravel. Part C says, is the amount of unprocessed gravel at the plant increasing or decreasing specifically when t equals 5 hours? Show the work that leads to your answer. First, we're going to take g and we're going to plug in 5. So I'm going to call up y1, which is our g of t, and we're going to plug in 5, and we get 98.141. Right here it says that the plant processes at a constant rate of 100 tons per hour. So what we want to make a note is that 98.141 is less than 100. Okay, so I have it written out. At time t equals 5, the rate at which unprocessed gravel is arriving is less than the rate at which it's being processed. Therefore, the amount of unprocessed gravel at the plant will be decreasing at the time when t is equal to 5. Part D says, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. We're going to use A of t to represent the amount of unprocessed gravel at the plant. So you have 500 is initially how much is unprocessed. Then we're adding the integral from 0 to t, because t represents whatever time in the day we want to calculate this at. The integrand is going to be g of x, which is the rate at which the unprocessed gravel arrives, minus 100, which is the rate at which the plant processes gravel. So to find the maximum amount of unprocessed gravel, we're going to take the derivative of this function. So to take the derivative of a, first we're taking the derivative of 500, which is just 0. And then right here, this expression is an integral. So to take the derivative of the integral, we're going to apply the fundamental theorem of calculus. So we're taking this variable and we plug it into the function right here. Once we have the derivative, we're going to set this equal to 0. So I pressed y equals, we still have g right here. So for y2, I'm actually going to call up y1, which is g, minus 100. So this represents a prime. We have g minus 100, and I'm going to go up and unhighlight this y1. So now when we go to graph, we'll only see the y2 function. Okay, I'm going to just adjust our window for x min is going to be 0, and then x max is 8 to indicate the workday. You can see that a prime crosses the x-axis right here, so let's find that 0. So I did second calc, and then we're going to select 0. We need a left bound, so I'm going to get a little closer, and you can see this y value is coming down, so we have y is 8, so let's go ahead and press enter for the left bound. Now we're going to go right, and right here we're right at the 0 for the right bound. Press enter, and then press enter one more time. Our graph is crossing at 4.92348. You can also see at this x value, A prime changes from positive to negative, indicating that A has a relative maximum at this x value. So to find the absolute max, we're going to use this as one of our candidates, and we're also going to check our endpoints. We're going to take the endpoints and that candidate, and we're going to plug everything into the function for A to find which one produces the greatest value. If you take 0 and plug it in, you have A of 0 equals 500 plus, and then this would just be 0, so you get 500. Next, I plugged in 4.92348 into our function for A, and you get 635.376. And finally, we're going to do the same and plug in 8. And we get 525.551. So you can see according to the chart the maximum value, and I wrote it out. The maximum amount of unprocessed gravel at the plant during this workday is 635.376 tons. Thanks for watching, and go ahead and hit that like button and subscribe to Math with Yosh. Thanks, guys!